Okay, so we are going to do proof by induction, the divisibility question. The question is that we have to prove 3 raised to the power of n plus 1 is divisible by 2 for all the integers where n represents the integer and it is greater than or equal to 0. For induction, there are 3 main steps you have to follow, which are: step number 1, you have to prove that it is true for P of A, where P is the proposition we have, which is this thing over here, and A is any integer. It is within the range of the condition given to us. In this case, we have n greater than or equal to 0. Number 2, we have to assume that the proposition is also true for all the integers. So if we take the integers to be k, then we have to assume that it's true for P of k. And step number 3 is that we have to prove that it is true for P of k plus 1 as well. So let's start with the first step here. Let's take our n to be 0, and then we have to prove it works for n equals 0. So I am just going to substitute 0 here and write that. That gives us 3 to the power of 0, 1 plus 1, which is 2. And we know that 2 is divisible by 2, so it works for n equals 0. Step number 2. We are going to assume that it works for n equals k, where k refers to all the integers. Whenever you have to write the second condition, make sure you always write the assumption. So 3 to the power of k plus 1 is divisible by 2. And now step number 3 is that we have to prove it works for n equals k plus 1. So I am just going to substitute k plus 1 in the equation. 3 raised to the power of k plus 1 plus 1. That is going to give me 3 to the power of k times 3 plus 1. Now, a very important step in proof by induction in divisibility questions is that the assumption you have taken, you can use this to solve the question. So here I have 3 to the power of k plus 1. I am just going to use this equation and I am going to write it like that. So I had 3 to the power of k plus 1. We assumed that this is divisible by 2. That means if I divide this equation by 2, it should give me an integer. M is any integer here. Because if it is divisible, that means whenever we divide it, it should give us a whole number, an integer. Now I'm going to rearrange this equation to write 3 to the power of k plus 1 equals to m. 3 to the power of k is equal to 2m minus 1. Now this equation where we have 3 to the power of k in terms of m is really important because it is going to help us solve proof by induction. So I'll take this equation here, 3 to the power of k times 3 plus 1. And I am going to substitute the value of 3k. So I am going to write 2m minus 1 times 3 plus 1. When I expand it, it will give me 6m minus 3 plus 1, which will give me 6m minus 2. And I can take 2 as a common factor, so I have 2 times 3m minus 1. Now if you notice, this number is being multiplied by 2. Since it is being multiplied by 2, we know that it is divisible by 2. And that is how we have solved this equation by induction. So the main thing you have to know is that you can always write the assumption in divisibility question like this here, and once you write it, you can use this equation in the third step. I forgot to write, this was the continuation of the third step. You can use it in the third step by substituting the value you've got from before, and that is how most of the divisibility questions are solved. I really hope you liked the video, and if something was not so clear, I'm going to make more videos on proof by induction, especially the divisibility questions, which isn't that hard, to be honest, if you get the trick. And if you like the video and you think it was helpful to you, make sure to also share it with your friends to also help them. Thank you.